Hello there, YouTube. I have put it together. Bam. Smell of hot resistors. What's going on? We have Dell 550 watt 12 volt power supply going to an OEM connector with a small switch just to turn it on. 10 gauge wire, silicone of course, going to an XT60. The XT60 branches off into 4 wires. Each one, these two are in parallel. These two are in parallel. These are 15 gauge. It was recycled from a hairdryer. You've got 4 terminals going on to the positive and the negative. This guy, well, he's the boost converter. It's got a fuse on the input. 4 60 volt. Wait, that's right. 63 volt, 470 microfarad capacitors. A freaking huge inductor. It has 4 wires in parallel. It is a MOSFET in the middle. And then it has 2 diodes going on either side. Double diodes, that is. TO220. 3 100 volt 470 microfarad capacitors. And the output. These are going to here, which is going to this meter. This is reading voltage. This is going down to here. Yeah, the electrons are flowing in the wrong direction. But coming out from here, going to here, into this. This is reading current. These are 3 coffee maker elements. This one reads 1100 watts, but I measured it as 13 ohms. This, I don't think it says, but it's 16 ohms. This is also 16 ohms. These element is, well, black is connected to the element here. And blue is connected to the element over here. Well, thermal cutout, thermal fuses element, which is connected onto there and there. This one, white, goes to the element, through the thermal fuses, and to this guy. This guy is connected through its cutoffs, through the element. So these are in, well, these two are directly in parallel. This guy is connected to the common there, but it's connected through this switch. This is one of the 120 to 220 switches. And this is connected. This is connected directly to here, which is connected directly to my positive coming from the power. This switch connects this wire, which goes to here, which connects this element and this element. And then of course all three elements are connected here, which goes along this wire back to the boost converter. Let's see what crazy voltages we can get up to before the power supply trips or something. Okay. Get you guys properly adjusted, and you can't see the current meter. Darn it. Much better. And of course, power supply is connected to my Wheat Energy power meter, and this is reading that on the Bluetooth. Yeah, you might be able to read that. Meh. I'll call it out when I see it. So, turn on the power supply. So we've got 12 volts on the output, and see that blue light? That is from the under voltage lockout, which is an easy way to turn this thing on and off. So, there we go, 40 volts, 2.5 amps. That's not much. But, as you might guess, I don't have the switch connected. Switching it from 16 ohms to 5 ohms. What's 5 ohms at 40 volts? How much current? My darn little potentiometer. There we go. 8.2 amps at 40 volts, drawing 30 amps on the input. Darn. Looks like the overcurrent is kicking in. No? I'm just not turning the potentiometer. I think I smell coffee. Okay. 35 amps on the input. And I don't want to go 40 because these are two 20 amp fuses. So, however, let's calculate efficiencies. 42.6, 8.8, 35. 42, 8.8, 35. 32.6. Let me get those real quick. So, we were getting 375 watts on the output, 420 watts, give or take, on the input. Because I don't have a meter on the 12, but I'm pretty sure it's just 12. And let's kick it back into high gear and measure what that's pulling from the wall. It is drawing 520 watts from the wall. Yeah, those fuses are getting pretty warm. Uh-oh. Did you hear that? One of these has clicked out. Wow. These are actually getting warm. Conductor's pretty warm, that's for sure. Oh, heatsink's warm. As the fan, I don't think it's kicked in though. So, my plan is, for these things, for these guys, is to make some sort of water cooling big bucket and shove some ice in it and let it make some coffee. But yeah, that's pretty cool. Scared me. Drawing 7.8 or 7.6 amps, which is 36.56 times 7.58, 277 watts, and 378 watts in. Is that fan finally on? Maybe. Let's cut this off. Oh, I'm not going to be able to test the fan, am I? Nope, fan's not running. There's definitely some cooking going on. That's for sure. This one's the hottest. It's probably the one that's cooking in. I think it could be this one too. So basically the thing is, what temperature does the fan kick in? It's running pretty toasty, that's for sure. uncomfortable to touch. It's only 42 degrees Celsius. There we go, 50. Well, 47. Okay. It's not 70 degrees, then probably not going to turn on. It's climbing. 50C. 51. 52. Now it's dropping because the heat is turned off. What? Oh. Shush. Where'd my hand go? I'll pause it for a minute. There we go. Got a fan set up. Blowing on there. This guy is at 53 degrees Celsius. Yeah, can you see that? A little bit. Power supply is getting a little warm. It's only, well, 200 now. Yeah. It's only half of its power. Yeah. $54. Oh, holy crap. Uh-oh. More cutting out. Alright. Oh wait, I need to leave him on. So yeah. It's almost 20. And yeah. Basically, overcurrent works. It's just you can't obviously go lower than 12 volts. So if you had a dead short, the short would go through there and probably blow the fuses out. There is some sort of MOSFET on the negative side, which they should have implemented. But yeah, Thanks for watching, everybody. I'll see you in the next video.